Okay, here I've got Pythagoras question number 4 from the quiz. It says, given the complex shape below, determine the distance of line segment AB. That's the one with the question mark on it right here between points A and B. It says round your final answer to the nearest tenth. What I've got to do here is realize that I have two right-angled triangles, one a little bit bigger than the other, and the smaller one kind of superimposed on top of that larger one. And I'm going to just outline that larger one in red. So what I'm looking for is the hypotenuse of that red triangle. Now I'm going to redraw these triangles just to make my life a little bit easier and keep my numbers separate. So this smaller one that's inside has a hypotenuse of 65 units. It has a side length here of 56 units, and I'm not sure what this side is. This larger one has the same side length, 56 here, but the only other thing I know is that it's 9 units longer on this side than this measurement here. So once I find the question mark in this triangle, I can add that to 9, which is the extra distance here, to get the total length of this side. Then I can do Pythagoras to get my final answer. So I'm going to start by writing out my Pythagoras formulas, and the Pythagoras formulas say that c squared equals a squared plus b squared is equal to c squared minus a squared, and a squared equals c squared minus b squared. So the important part is going to be to label each of the triangles properly and then work with them separately until I can work towards getting a final answer. So over on this triangle, my right angle is here. I'm going to call this side C because I know that that's the longest side across from the 90-degree angle. And sides A and B, once C is in the right place, can be put anywhere. So on this triangle, I'm looking to solve for side B. And I know that b squared equals c squared minus a squared, and I can fill in my numbers. So b squared is equal to 65 squared minus 56 squared. That means b squared is 65 squared gives 4,225 minus 56 squared, which is 3,136. Now I can carry out that subtraction. 4225 minus 3136. b squared is 1,089. And of course I wasn't looking for b squared, I was looking for b, so I've got to take the square root of both those numbers, or both sides of equals, and the square root of 1,089 leaves me with 33 units. So this measurement over here is 33. That represents the distance from point C to D here. Now I can see that the whole side of this large red triangle is going to be 33 from here to here, plus the 9 that's there. 33 plus 9 means that that side length is 42 units from top to bottom. Now I can see that I've got a side length of 42, a side length of 56. I can find that third side using Pythagoras. So over here I'm going to label my triangle with side C, my hypotenuse, across from the 90-degree angle as always. Sides A and B can go anywhere I want them to. Since I'm trying to solve for C, I'm going to write out c squared equals a squared plus b squared and fill in the numbers that I know. So c squared, a is 56, so c squared equals 56 squared plus b squared. Side B is these two numbers together, 33 that I found over on this triangle, plus the extra 9 is how much longer this side is than this one here. So a total of 42 on this triangle for side B. And that means c squared is equal to 56 squared was 3136 plus 42 squared, 1,764. So I'm going to add these two numbers together. That'll give me c squared, 3136 plus 1,764. c squared is 4,900. I wasn't looking for c squared though, I was looking for c, so I'm going to take the square root of both those sides. And that leaves me with an answer for c of 70 units. That's the final answer to this question. Even though they wanted it rounded to the nearest tenth with no decimal, I can leave it just the way it is.